So I'm going to start with the information. All right, what we're going to do for this proof here is I am going to talk you through some of the sort of structure of how you identify the statements as well. Hey, but do know on your homework and on your quizzes and tests, it'll provide you with the statements on your own. Okay? So when you are completing a proof and you have to come up with the entire statement and reason sequence on your own, I would suggest one of two strategies. Okay? The first one is to interpret any definitions or any relationships that are given in that initial state, the given statement. Okay? The other one would be try to introduce your end state elements as early as possible. So those are the two strategies, and you're going to do both of them. It doesn't matter which one you do first. Okay? But oftentimes what I will do is I will interpret the given information. Okay? So the given information is angle 2 is supplementary to angle 3. So what does that tell us about angle 2 and angle 3? They add up to what? And the reason for that is? Okay, and remember, you have to use the definition of whatever word appears. Bless you. Okay, so it has to be exactly the word that appears. You can't make an inference based on a relationship. Okay, so if something says it's perpendicular, you can't say definition of complementary, even though being perpendicular might be complementary or might be a right angle. If they tell you it's perpendicular, you have to use perpendicular. Okay, so here we have to use supplementary. Okay, now, really this statement can only be one of a couple things, right? It's either definition of linear pair or definition of supplementary or possibly SSI. And so to know what could possibly even justify a statement is often going to be helpful. All right, so what I've done here is I have interpreted the given information. Okay, so the next thing that I'm going to do is I'm going to start to introduce the end state elements that aren't already in my proof. So angle 2 is already in my proof. Okay, angle 1 is not in my proof yet. So what I need to do is I need to figure out a way to introduce angle 1 into my proof. Okay, and since I know the angle, and again, often with proofs you work your way backward, okay, which is why you try to introduce those end state elements. So as I kind of work my way backwards here, in order for angle 1 and 2 to be equal, so there's no connection between them at all. The only thing that connects angles 1 and 2 would be a statement, and the only way that the statement comes in is that angle 2 is part of this equation. So can I introduce angle 1 in an equation that's similar to the equation containing angle 2? What do I know about angle 1? Angle 1 plus angle 4. And again, this is not the only statement, but this is a good way to introduce that. Okay, and that's equal to 180. Now, could I have taken angle 1 plus angle 6 equals 180? Yes. If I did that, then again, we have to relate it somehow to 3 as well. Well, 3 and 6 are equal because these are corresponding angles. What about angle 4 and 3? Are those equal? By what? Alternate exterior angles. So I could have done either of those. Okay? So it doesn't matter. This statement could be either of those forms, but regardless of what I choose, the justification is going to be definition of linear pair. That gives me the sum of those adjacent angles that form a straight line is 180. Okay, and now as I start to build from this, I have two statements that are equal to the same thing. So what can I say about those two statements? Okay, and since I want to prove that angle 2 is equal to angle 1, I'm going to put the statement that has angle 2 first on the left. Again, it just prevents me from having to do symmetric property for something, but if I say angle 2 plus angle 3 is equal to angle 1 plus angle 4, and what justifies that? two things, each of these appear earlier, are they set equal to the exact same thing? Yeah, so it's not just substitution, but also transitive property. Okay, and so now as I, again, can kind of continue to think forward and work back, I need to show that 2 and 1 are alone on one side of the equation, so somehow I need to remove angle 3 from one side and angle 4 from the other side. And so thinking about those, can I make the statement that those are equal to each other? And what is the reason that those are equal to each other? They're alternate exterior angles of parallel lines. Again, we were told that M and N are parallel in the givens. So by AEA, I have angles 3 and 4 equal, and that leads me to my final conclusion, that measure of angle 2 is equal to measure of angle 1, because what did I do with this statement from step 4 in order to get to the statement 6? Subtracted angle 3 from one side, so I have to subtract an equal value from the other, right? If equals are removed from equals, then the remainders are equal. What's equal to angle 3? Angle 4, so I removed equals from equals, and that is subtraction property. Okay, and so that would be the justification for this proof. But I could have also said angles 1 and 6. If I had said, if I had changed this here to measure of angle 1 plus measure of angle 6 is equal to 180, right? It would still be definition of linear pair. But now I have my answer here. Instead of angle 4, I have it angle 6. And so when I go to this step here, I need to somehow try to relate angle 3 and angle 6 together. Well, angle 3 and 6. Angle 3 is equal to angle 6. That would be corresponding angles. And then I could use subtraction property here. So depending on which pair that you saw or wanted to use, or that the proof gave you, you could base it on that information.